Right, good morning everybody. As David said, my name is Shaun, G8VPG. I come from Bristol. I'm part of the GB3ZZ team. And the purpose of the talk this morning is to tell you how I've assembled my 146 megahertz reduced bandwidth TV station over the course of the last 18 months or so. Just a quick reminder about this new 2-meter allocation. It's an extra 1 megahertz at the top of the 2-meter band. There is a power limit of 25 watts ERP, a maximum aerial height of 20 meters. It is available by an annual notice of variation, which you have to apply to the RSGB for. It's available to full license holders, and there is no particular qualification. You simply apply and it will come to you by return. You can't use it in the Isle of Man or the Channel Islands, and there is a slight restriction on the upper frequency limit if you are within 40 kilometres of the Scottish border or the Scottish coast. Don't ask me why. 146 activity has settled around these parameters. The frequency 146.5 megahertz using DVB-S modulation, H.264 codec. Symbol rates, the maximum symbol rate 333 kilosymbols per second, but we can reduce that down to 125 with the present equipment. And we have found, in fact, that where a QSO has been struggling on 333, switching to one of the lower symbol rates makes quite a difference. And certainly out portable, it's made the difference between achieving a contact and not doing so. FEC normally 7/8, and the sound is usually disabled, not always, but the sound does pinch some bandwidth out of the video, and when the bandwidth is this narrow, you want all of it going into the picture most of the time. So the simplest form of transmitter for reduced bandwidth TV is the Raspberry Pi, and using the software written by Everest, it is possible to generate a signal directly from the Raspberry Pi without any extra hardware. It uses a harmonic of the computer clock oscillator, comes out on 435.7 megahertz, so not strictly speaking 2 meters. However, it's probably how most of us generated the first RB TV signal going back 18 months, 2 years ago, and for test purposes across the shack, it's very good. But it is a rather dirty signal, so it's not really suitable for transmission purposes. For transmission purposes, the Digi Thin is the first option to consider. This is a modulator board that sits on top of the Raspberry Pi, and it generates a fixed symbol rate of 333 kilosymbols per second, and it works extremely well. It needs an external carrier oscillator, and the output level is very low, so it needs some filtering and amplification, but it does work extremely well, and the BATC did have a printed circuit board available for this. I don't know whether they are still in stock. No, Noel is shaking his head. Okay. There's been a further development along similar lines, which is the RB TV mod board. And this is a similar modulator board which fits on top of the Raspberry Pi, but it has the advantage of allowing a variety of symbol rates between 500 and 125 kilosymbols. I haven't used this myself, but Colin, G4KLB, has been quite active building and helping with the development of these. So if you watch the SQNet on a Sunday evening, Colin will often update you on how this project is progressing. As I mentioned, both of those modulator boards require a carrier oscillator. And this is the carrier oscillator that I used. Richard, G8BYI, who is a member of the Bath GB3UT group, has made a circuit board for the ADF 4360 frequency synthesizer chip. And he does a whole variety of these for different frequencies, either fixed frequency or variable frequency. This one I asked him to make up for me. It's a fixed frequency, 146.5 megahertz, and he was able to tailor the output to the exact level required for the Digi Thin modulator, and it works extremely well. I would advise you to get him to make this for you, because the chip is very small and it's one of these devices where you really need to put it in an oven or on a hot plate to solder it. It's completely impossible to solder it by hand. Probably the final option for reduced bandwidth transmission is the DaTV Express transmitter, which many of you will be aware of. This is a very flexible software-defined transmitter. It will operate on all bands from 70 megahertz to 2.45 gigahertz, and the oscillator is built onto the board, so you don't need a separate carrier oscillator for this. And what has really made a big difference this year is that there is new Windows control software for this board. And certainly I didn't use the board until the Windows software came along, but the Windows software works really well. It's very easy to use, and I know quite a number of people who have bought these boards and started using them now that the Windows software is available. I use a free program called Vmix, which is a video production program. It's available in a variety of options. There is a basic free version which does everything that I think we as amateur television enthusiasts need, but if you're into video production, there are more capable paid-for versions. But it gives you the facility to have 4 inputs and to have things like test cards, which are just a JPEG or a caption, and you can do all sorts of tricks, mixes and wipes, etc. But the great advantage is if you click the external button on the software, it will generate an internal transport stream that the DVBS, the DATV Express board can pick up directly. So it makes driving the DATV Express board very easy. This is the control program for DATV Express. And again, it's a very simple program. You can set frequency, symbol rate, FEC, etc. And it's possible to have preset configurations saved as a file so that you can change frequency or symbol rate very easily. And the output from the board is variable in, I think, 47 steps. So you can get the drive level for your amplifier set very easily with this. All of these transmitters that I've discussed have one thing in common. They have a very low output level, none of them more than 10 milliwatts. So you will need quite a lot of amplification to generate a meaningful power, and also some filtering to remove harmonics. Now, one of the problems with digital television transmission is that you do need very linear power amplifiers, Class A amplification with lots of bias current, and the amplifiers have to be quite severely derated to keep them in a linear zone. I have found that a certain amount of test equipment is pretty much essential if you're experimenting with this mode. I've got a spectrum analyzer which you can see over there, and I found that to be essential experimenting with new amplifiers. I appreciate that a lot of people won't have an instrument like that, and I think if you follow an established amplifier design and keep to the settings and the ratings which have been established by others, then you should be fairly safe. But if you're experimenting with a different amplifier design that's not been used for this mode before, you really do need to check it out on a spectrum analyzer before you put it on air, because it's very easy to generate an excessively wide signal that goes outside the band limits. The first amplifier that I experimented with for this mode is based on a Mitsubishi 8-watt module. And this is available as a circuit boarding kit from SAM G4DDK. And it works very well. It's got a low-pass filter built into the board. The one thing I've found with all of these Mitsubishi modules, and I've used them on 3 different bands now, it's very important that the module is securely earthed back to the circuit board that is driving it. And what I do is I put a couple of solder tags on the 2 bolts that hold the module down and solder those back to the circuit board. If you just rely on the metal backplate of the module for earthing, it tends to be a bit unstable and you'll see the power meter flickering a bit. But if you earth it securely back to the circuit board, it tends to eliminate all of that. This module is available from a company called Anglia Live in the UK. I think it's about £25–30. This is the output of the module, and this is running at 300 milliwatts output power. Now, bear in mind, this is an 8-watt rated amplifier, and at 300 milliwatts, the spectral regrowth shoulders are about 40 dBs down, which is quite acceptable. If you increase it to 1.3 watts, you can see what happens. It starts to get wide and you get secondary shoulders building up. You can push it up to about 2 or 3 watts, but it really is getting rather wide there. So when I started experimenting with this amplifier, I thought 8-watt amplifier, 25 watts ERP limit, this should be okay, but it's not powerful enough really. It makes a good driver amplifier for the next stage, but by itself, you really are limited to about a watt or so of clean power from it. However, it has a very good low-pass filter in the output, and this is the characteristic of the low-pass filter. Very low through loss. It starts to cut off at 160 megahertz, so it works very well, and in fact you could extract this filter and use it with other amplifiers if you wanted to. And that is a look at the output up to 1.5 gigahertz, and there are no harmonics visible, certainly 55 dBs down on the main signal. So the low-pass filter works very well. We needed more power, so we went to the next module in the range, which is a 60-watt module. And in fact, this is reputed to run 80 watts in amateur narrowband modes. I haven't tried it in narrowband actually, but the Mitsubishi rating is 60 watts. Again, a circuit board is available from SAM G4 DDK, and the module is available from Anglia Live. The module is about £40 to buy. And Roberto, DG0VE, does actually produce a ready-made version of this amplifier if you don't want to make it yourself. The same design of low-pass filter is present on the output. And here is the amplifier running at 8 watts. Now bear in mind, this is a 60-watt amplifier. This is running at 8 watts. The shoulders are about 40 dBs down, which is a nice level to run at. It's about as much power as you're likely to need for 2 meters with the present ERP limit. You can push it up to 15 or 20 watts, and in fact, I did do some experiments with a vertical omnidirectional aerial with this, and it worked surprisingly well. I was able to get pictures across Bristol, about 9 miles or so. But if you're running into a beam, you're probably going to be running 5 to 8 watts, something like that. It needs a 4 amp bias current to get it into its linear zone, and it takes about 6 amps when it's running at this power level. So you do need a good heatsink and fan when you're operating this device. And there is the completed amplifier, which is down on the table there. I used the previous amplifier as a driver amplifier for it, but you don't probably need it. Because I built it, I used it, but I had to put quite a bit of attenuation between the stages to stop it overdriving. I think probably most people use these with a DaTV Express board without any other driver amplifiers. Moving on to reception. The standard satellite set-top box that we use for repeater reception is not suitable for reduced bandwidth television. They're specified to about 2 megasymbols. Some of them will go down to 1 megasymbol, but they certainly won't go any lower. So you need to use to tune or mini-tune software, which works extremely well down to 125 kilosymbols. There is some work going on now with RTL dongles and a program called Lean DVB, which I haven't got experience of myself, but that is another alternative approach. This is my first mini tuner, which I built before the BATC circuit board was available, and it was built onto Vero board. The original to tune software ran with a specific type of satellite tuner card that fitted into a PCI slot in a computer. But the card became obsolete, and PCI slots are not very common on computers now. So luckily Jean-Pierre was able to find this NIMH Tuna and the USB module, and this will work with any USB connection. It will work with all symbol rates, and I'm sure, as many of you know, it works extremely well. Here is the production one with using the BATC circuit board. And most of the hard-to-get components are available from the BATC shop. The latest tuner which is in stock is the Sharp tuner, which tunes from 650 megahertz to 2.6 gigahertz, which gives us a slight problem with 2 meters and 70 centimeters in that it doesn't tune that frequency directly. So you need some form of up converter to convert 2 meters up to the tuning range of the satellite tuner, the NIMH Tuna. This is my first Homebrew Up Converter, which uses a variety of components, old and new. There's a mini-kit preamp in there, feeding into a Homebrew bandpass filter, which needs to be put into a screen box, and that goes into a mixer. There's an old G4DDK 1152 meg source from a transverter project, which, because the output is rather low, needs a mimic to boost it up to the level the mixer requires. And then on the output is a satellite line amplifier to give some extra amplification at 1200 megahertz. Now, it took me a bit of a while to get this sorted out, actually, and I blew the preamp up because the original preamp was a PGA 103 based device, and if any of you have used this device, I would say don't use it because they are unreliable. And I actually managed to blow up 2 mixers as well. I'm not quite certain how I did this. So at the start of the summer, with activity weekends are coming and no working up converter, I thought I've got to sort something out. So I bought one of these, which is the ready-made up converter from Roberto, G8VPG. Now this does all of that in one little box. It's powered up the coax from the mini tuner. It's got a 0.4 dB noise figure preamp in it and 50 dBs overall conversion gain. But there's a few things you need to watch for with this little box. The first of which is it draws 300 milliamps of current up the coax from the mini tuner. And the polyfuse in the mini tuner, I think, is rated at 200 milliamps. So you need to remove the polyfuse, and I've put a wired fuse in there so that you can get the correct power to it. The other problem, which you don't realise until you've played with it, is the correct choice of local oscillator frequency. It's got 4 local oscillator frequencies which you select by little jumper pins inside, and when I first had this, I thought, let's make the arithmetic easy and we'll choose 1100 megahertz as the local oscillator frequency, and I can add 146 to that quite easily. But it was a big mistake because you can see from this picture that there's quite a lot of bandpass filtering in this, and if you choose 1100 as your local oscillator frequency, the output comes 10 or 12 dBs down this bandpass curve. And so you need to choose 1130 as the local oscillator frequency to get it at the peak of that curve. But he doesn't tell you this in all the bump he sends you. You could realign the filtering on it because it's tunable helical filters, but I didn't particularly want to get inside it with a screwdriver on a brand new item. So that's the first thing. You do need to choose the 1130 local oscillator frequency. And it worked very well at that frequency. And so we thought down in Bristol, we'll put a 146 input into GB3ZZ. And so we bought another one of these. And we got it all boxed up, it's over there, and took it up the repeater. And when we did the first trials, we were using a different form of up converter, a local oscillator mixer module and a separate low noise amplifier. It worked beautifully. I could get in on 2 watts output from the other side of Bristol. We put this one into the repeater and we couldn't get in. And this was the reason why. The big spike on the left-hand side is the local oscillator at 1130. But also present were these little spurs at 20 megahertz intervals through the pass band. And one of these happened to be at 1270 megahertz, which is 6.5 megs from our output. And of course, Minitune was not having any of this, and it wouldn't lock up at all. So once we discovered all of this, we sent this particular tuner back to Roberto in Germany, and he replaced some capacitors in it and put some of this sticky black foam in. And it all seems to have calmed down quite well now. But in fact, 3 of us have got these devices down in Bristol, and we've looked at them all, and these spurs are all there to a lesser extent. So if you do buy one of these, you do need to check that quite carefully. Okay, that's the end of the slides. What I'd like to do now, you're probably thinking, what does this actually look like on air? And I've got a little bit of video saved earlier in the month when Noel was up at Clee Hill. So Dave, if you could cue that video, please. Yes.
Whilst Dave's doing that, there is another Raspberry Pi based solution coming up out of France, and there'll be an overview article in this next CQTV, which that looks quite a nice solution. They put it together with a touch screen and everything.
Let's open the door. Not doing that there. Yes, they can certainly hear our audio. We took what we're saying. Think about this. We seem to display more video on. No worries. Oh, come on, decode it. Don't do this to me. I can decode everybody else, but I can't decode my own. It's a duplicate setup, the station monitor. £10 car monitor from Amazon. Yeah. Yeah, it's yours. Who is it?
168 kilometres. Briefly a world record.
Have different roof cams or antenna cams. And
Yes. Yeah, I think we finished it now. Okay, well, I think you can see that the picture quality is not bad. It's not HD video, but it's usable video, and if you're old enough to go back to the 1980s with 70 centimetre AM TV and reduced bandwidth video IFs, etc., the picture quality compared to that is pretty good, and this is on a VHF band, and of course Same technology could be used on 6 meters or 4 meters as well. I have a handout sheet which I've prepared here, which has got all the references for the various items of equipment, pieces of software. So please take a copy of that with you. For those of you watching on the stream, this has been put onto the BATC Wiki 146 megahertz page. So you can read this page there. Are there any questions?
What was the single rates of the demonstration?
That was 333 kilosymbols. So that was the maximum that we could use on 2 meters.
Half a megahertz.
Yes, yes. I mean, when you go down to 125, there is a noticeable degradation in picture and video quality. But nonetheless, it's a usable picture. And for contest or whatever, it's perfectly adequate. Yes.
Is pre-distortion possible for linearising your amplifiers?
I'm sure it is, but I don't know how to do it.
Charles has looked at doing it on DaTV Express, but it's just too complex. Absolutely.
What was the eventual shoulder level that you accepted for transmission there?
About
You
sort
can
of.
say.
I don't like to go transmit more than 30 dBs down, but
So it's more than 30.
no, that is the sort of maximum. I mean, normally it's about 40, 35, 40. This amplifier will produce. I mean, at the moment we're severely power limited on this band. In fact, as you can see, I've brought all the kit along today, and with the test equipment, so we can come and have a play with this, and I can show you exactly what it will do afterwards, because it's all set up and working.